Today, we will see how a simple rate becomes a supercomputer microchip.
Welcome to the first step. This high-purity quartz sand is the raw material for every supercomputer microchip we make.
The first step in creating a supercomputer chip is purifying the raw quartz sand. This vibrating sieve removes the initial coarse impurities. Tapped directly from the arc furnace, the molten silicon rushes into preheated molds, where it begins the cooling process.
Inside the Siemens reactor, purified trichlorosilane gas reacts with the heated starter rods.
The upper plate lowers and begins rotating, simultaneously flattening both sides of the rough wafers, removing saw marks. The lapped wafers now under wet etching, submerged in a chemical bath that dissolves the damaged silicon before a high-pressure rinse. How sand becomes a supercomputer microchip, the full process. Manufacturing a supercomputer microchip from sand.
Now begins the most important part, photolithography, where we print the circuits.
We are now in the photolithography bay. The automated system loads the wafer into the spin coater to apply the light-sensitive photoresist.
How sand becomes a supercomputer microchip, the full process. Manufacturing a supercomputer microchip from sand.
Radio frequency power ignites the plasma, causing ions to strike the exposed silicon, cutting vertical trenches into the surface.
Inside the chemical vapor deposition reactor, the wafers rotate as a gas mixture deposits a thin insulating layer of silicon dioxide.
Next, the wafer enters the spin coater for the photoresist, followed by UV exposure in the stepper, defining the contact layer with incredible precision.
How sand becomes a supercomputer microchip. The manufacturing process.
How sand becomes a supercomputer microchip. Full process. Manufacturing. Supercomputer microchip from sand.
Para Seco packets. Let's see again who you turn the sand into a supercomputer microchip.
The sand was melted at 2,000 degrees, creating molten silicon, and the Czochralski process.
We then saw the ingot with a diamond and polished the wafers to a smooth, glassy finish where nanometer-level circuits can be printed.
Finally, the wafer is diced, each die is mounted on a green board, wire bonded, and a heat spreader is placed on top.
Circuit printing, i.e. narration, and looking
Think of it like the sand that is on the beach or in the desert. Here we are, becoming supercomputer microchips, solving the world's most complex problems.
It was a journey from poverty to a supercomputer microchip. If you enjoyed this deep dive into manufacturing, don't forget to like, share, and subscribe to the channel.
The molten silicon begins to cool, forming a perfect cylindrical monocrystal ingot, ready to be sliced into wafers.
How sand becomes a supercomputer microchip. The full process.
Following fabrication, the chips enter the reliability lab, undergoing rigorous burn-in qualification in these
To ensure reliability, these supercomputer microchips are subjected to rapid vibration, measuring the G-force levels.
All layers remain intact, even after stress testing.
Even a speck of dust can damage the wafer here, which is why we practice such strict cleanroom discipline. So when the gate voltage is applied, the channel opens up, allowing the electrons to flow from the source to the drain. This is the on state.
From sand, we derive the silicon layer.
It starts with a single microchip on this board, but as you can see, it scales up to power this entire rack.
They are both actually made of the same element, silicon, which is what the RateMe is hiding.
A supercomputer microchip takes days to make, but when you're ready, it performs billions of operations every second.